staying by domain and range. The graph's going to go all those directions forever. The y-intercept. Okay, so I'm going to have my highlighter here. Hold on one second, Jamil. My highlighter's right here. Yeah, that's my y-axis. So, Jamil, what is it? Is that what you were going to tell me what it was?
I was going to mother that and another thing. With domain and range, does it always look like that?
For cubic functions, yes. For functions that go forever up and forever down, yes. That's how it's always going to look. But the y-intercept right here in green is 0, 0. Okay, because that's where it crosses that highlighted piece. And in blue is my x-intercept. Okay, that's my x, that's my y. Every single time it crosses, so it crosses here at 0, 0 again. It's okay to list it twice. So 0, 0. It also crosses at 2, 0, where my finger's at. And it also crosses at 4, 0. So that's why I have 3 x-intercepts. Yes,
0, 2, 0, 4.
Okay, so 0, 4 would be right here. That's 0, 4. That gray piece right there, or this red piece, that's 0, 4. That means you go left, right, nothing, and you go up 4. So be careful with how you write it. Question?
Yeah. How is the 0, 0?
So it crosses the x, so here's my line. It crosses the y, and then it also crosses the x. So it's okay to list them as both. Yes? It's okay if you have different order. Yeah, if you put 2, 0 first, as long as you have those exact intervals, then you're good. Okay, good questions already so far, so good job. If you need a graphing calculator, make sure you grab one. We're only going to use it for a little bit today, not as intense as yesterday. Today, in my opinion, is one of those easy days because chapter 4, it's just like chapter 4. If you were good at saying, hey, it stretches by 2, it compresses, it moves left, it moves right, it moves up, it moves down, that's what we're doing today, but instead of having squared, we're doing cubed. Okay, not too different. It went very well last period because people remembered it from chapter 4. We spent about 4 or 5 days last chapter just on transformations. So if you can get out your orange packet of notes and go ahead and flip to day 3. Day 3. All the way to here. Whenever you're ready. I promise today is a lot easier and it might explain some things that maybe you got confused on last chapter. I really try to make it so that you could actually understand what you're doing and not just memorizing the transformations. Okay, but let's talk about, oh wait, some people are still getting it out. There's a couple of people. Please let me know if you can't see something. Okay, this is a new computer, or a loaner, I should say, so it's going to be a little different. I do use highlighters for this. If you like them, let me know. I can throw them to you. Okay, describe all the transformations performed on the parent function x squared. Remember, the parent function is just like the original with nothing moving. Okay, remember x squared is that u. This is what we learned about last chapter, so we're kind of reviewing last chapter. And then produce g of x. So g of x is going to be this new function that we transformed from the parent function. So I'm going to highlight every single piece that's different. This is what we did last chapter. I highlight the negative, the 2, the -3, and the 7. That means that there are 4 different transformations that I just highlighted. And look what's left, x squared. In my directions, it says the parent function is x squared. That makes sense. Okay, so I highlighted all 4 pieces. Remember the negative right by the equal sign. That told me reflect over the x-axis. Remember last chapter I said it was super important that you put reflect over the x-axis because in chapter 5, which we're currently on, we'd be talking about the y. We will be talking about that today. The only new part about today is the y-axis. Yes. Good. I could throw any. Raise your hand if you want highlighters. Okay, 1 and 2 and 1, 2. There we go. Getting my skills in there. You're good.
Why is this smiling
Because sorry, we came in hot there. Woo, there you go. Did you see one somewhere back there? Good? Everyone else is good? Okay. So the 2. Does anyone remember if we stretch or compress if I have a number greater than 1, which is 2 here? Would I stretch or compress for this? This is from last chapter. See if you remember. Would I get tall and skinny stretch, or would I get small and compress? Stretch. If I took you and I multiplied you by 2 or made you twice as tall, you would get skinny. 1 second. Stretch by 2. And we'll review everything. Okay. Now, this 3, that means either left or right. Does anyone remember if the -3 means left or right? I heard a couple different things, and someone was right. I heard right 3. Remember, it was always the opposite of what you thought when it was in the parentheses. That was the most common one that was wrong on the test. Now, the 7 means up or down. Am I going up or down 7? Very good. Okay, so those are all the transformations of this function. I reflected over the x, which means that I went down. I stretched by 2, which means I got skinnier. I went right 3, and I went up 4. And we'll talk more about like what each of those mean in a second here. You did go up 7. Oh, sorry, up 7. Thank you. Okay, let's look at this next one. I have this piece, I have this piece, and I have this piece. Yes.
Can I?
Yep. Jamil, what does 1/3 mean? If it was negative, I would say yes. Okay, so if you had a negative like this right here, I would say yes. Now, you have the option of stretch or compress. This one's 1/3, so compress. Very good. So compress by 1/3. Remember, that means you got like, if I took you and I smashed you 1/3 of the way, you're going to get wider. Okay, because think about your body. If I took you and you see those really tall, skinny models, okay, they're really tall. That's why they're so skinny. They could weigh just as much as me, but they look skinnier than me. That's just how it works because you get stretched out. Whereas compressing, I can smush you and you get wider. Okay. All right. The +5, would that mean left or right? Very good. Left. 5, and then the 9, up or down? Down. 9. So today is exactly the same thing. The only new thing that you're learning is reflecting over the y-axis. That's it. Everything else is the same. So like I said, it's a pretty easy day because hopefully it might come back to you as we're going. Now I am going to go in detail on explaining a little bit more what you're doing so that you understand and you're not just memorizing. Okay? So, yes. Uh-huh. Okay. So for these ones, you see the dotted line there. Yours might be a little more faint than mine is on your notes. If you have a highlighter, then I want you to highlight the dotted line because that's what we call your parent function. When I was talking about that earlier, that x squared, now we're talking about x cubed actually. X cubed is our parent function in the situation. Now you can even look from here. 0, 0. If I move this graph right here, what's going on? Am I moving left, right, up, down? What's going on? I'm moving left. Okay, that's the situation here. And look, that's what we talked about earlier. If you have a plus sign inside the parentheses, we're moving left. And you can actually see that. Maybe draw yourself an arrow so you can visually see. If you graph it on the graphing calculator, you can actually see from 0, 0 right here, you can see it moved left. So if you get stuck on the test or whatever it may be, use that graphing calculator to help you out. Okay, I'm going to move down. Now this is the same situation. I would keep highlighting your parent function so that you know what direction it's moving. Yeah, because look, you're moving to the right. Here's my arrows. I'm taking this and I'm moving to the right. So yes, I am moving right. Just kind of so that you can visually see what's going on. And that was when inside the parentheses we had a negative. We did that example above.
Is it ever going to move diagonally?
It will never move diagonally, no. Huh? The first one was left,
Oh,
and the second one was right.
I want to know about this one.
This is the one, yes. The parent function is always going to go across the 0, 0. And in your notes, I try to make it a dotted line. That's the one. The parent function is always going to be that one that goes through 0, 0. Yep. This is the only new one out of all of them. Out of every single one that we're talking about today, I put a star here. It's the only one that's new from last chapter. All the rest of them are the same. When you have a negative inside the parentheses this time, you're going to be reflection, but now we're going to reflect over the y. It did not matter when we were working with x squared, because if I reflected, it became the u still. However, with these ones, it's a little different. And I'm going to highlight, again, my parent function so you know the difference between the two. Look what happened. Here is, I maybe use a different color highlighter for this part. Here is my y-axis. Look at what happens. It reflects over the y. Reflects over the y. That's what's going on. After you're done with your highlighting, I'm going to explain it one more time of why this is reflecting over the y. Because some people are really visual learners and it helps. If I were to take, like pretend I'm actually grabbing the graph. If I were to take this piece right here and reflect it over the y, that's why that's there. If I take this piece and reflect it over the y, that's why it becomes here. That's what it means when you're reflecting something over the y-axis, okay? All right, now let's talk about the y's. So that was all the x's, all the transformations on the x. Now let's talk about the y. If I have a plus k here, would that mean up or down? Up. And here's my original graph. You can see here that it moves up. And again, I'm not really asking you to memorize all this stuff. I'm just trying to get you to conceptually understand what's going on and not just memorize that plus k means up. Okay, just so that you know. Yes.
So that's what was reflected.
It was reflect. Yeah. Okay, this one, the minus, it means down. I feel like we all know that part. We're on the right side of our chart. Okay, remember, this is my original, the dotted line here.
What was the first
Up. And you can see here that I am moving down. Moving down. Okay. That way, again, if you get stuck on the SAT or, on the test, you can put it in your graphing calculator and you can actually physically see it. It looks like it moved down. Okay. Now we're stretching and compressing, and I kind of already explained this by saying if I was a model and I was really tall, I would get really skinny. Stretching. Okay. Here's my original, that dotted line, like this. Okay, mine's kind of big, but you can see here it gets skinnier, it gets taller, it gets skinnier. It like stretches up. It's like if you pull it and you stretch them up. It's like stretching up, stretching down too. Then we have compression, and that's when we had that fraction. And a lot of people always ask me, how do you know if it's stretching or compressing? Like 1/2, 1/3, that means that you're compressing. And you can take a look here. Here's my original there. Okay, it gets wider. Look at it, does get wider. If you actually think about it, it's getting wider than the original. Okay, that's really what it means when you're compressing something. I know this might be not the funnest thing in the world, but I'm trying to get your brain to understand what you're doing and not I'm not just saying, hey, it compresses by 1/3. Do you know what that means? Hopefully you do now. You know that 1/3 means that your graph is getting wider. Okay, now this is the other one. This is still reflection. But now we're reflecting over the x-axis here. And I'm in a second, once everyone's done writing, I'm going to write something important to know the difference between the two when you're looking at a function and how if it's reflecting over the x or reflecting over the y. I'll highlight this one so that you remember. Here is my original. Here is my x-axis in blue. Sorry, my highlighters are really big because I don't have my normal program. You can see here with your arrow, it reflects over. It reflects over the x-axis. You can see it actually reflecting over that blue line. Okay. Okay. I'm going to write something important here next to each other. And make sure you write this down and you're paying attention. You can see the difference between the two. Reflecting over the y-axis, you're going to have something like g of x is equal to a negative x inside the parentheses. Let's say cubed. What the difference is, here's the x. The x would be something like g of x is equal to negative outside the parentheses. I know that's kind of weird to think about, but it does make a huge difference if it's inside the parentheses and if it's not. Okay, that makes actually a really big difference in your calculator. So that's how you know the difference between the two. One, it's like if for the x-axis, it's right next to the equal sign like I taught you last chapter. Now it's not next to the equal. There's a parenthesis blocking it. It's like blocking it. Hey, blocking that equal sign. So it's going to be the y-axis. Flip when you're ready to move on. It's actually really easy to graph these. Because we're doing very well so far. Okay, so it says, generate the graph of each cubic function, determine the transformations. So before I do anything, I'm going to determine the transformations. I have a plus 2 here, and I have a minus 1. What does the plus 2 mean? Very good. Left 2. Whenever you're inside parentheses, that means left or right. Outside the parentheses, what does a negative 1 mean? Down 1. When you graph these out, you take what you just wrote, and that becomes your first point on your graph. So I'm going to draw an arrow here. I think it's important that you draw an arrow too, so that when you look back at your notes, you know where it's coming from. Left 2, would that be a negative 2 or a positive 2? Very good, negative 2. And then down 1 would also be negative 1. Remember we did that way back, chapter 4. I put 2 below and 2 above, so I'm going to put like negative 3 and negative 4 because that's below 2. And I'm going to put just negative 1, 0. Again, I just went in order on the number line. And you could just do it in your table in your graphing calculator too and you get it. Yep.
That row also applies to the y section.
The which one?
The y section.
So the y, no, we actually have to find the y. There are 2 ways to find the y. You can plug it into your graphing calculator by just putting in negative 3 here, or you can just put it into your actual y equals, and I'm going to do the y equals with you guys. Okay, so get out your graphing calculator. Here we go. It's actually pretty easy. Press y equals and clear out what you have in there. Even if you have something in there, don't cheat. Make sure that you know how to put it in. So I have parentheses x, and it was plus 2. Close it up. Here's how you get the cube if you weren't here yesterday. There is an arrow. Use the arrow, and then press 3. That's how you get the cube. Now to see how it's still flashing up here. If you were to type still, it would go up there. Yeah, you got to go to the right to get it down. And I think it was minus 1. Okay. Now we really don't need our graph. We just need our table. So I'm going to press second, that blue button right here, and then graph. And that's going to get me my table. And you can move up, you can move down until you see the numbers you want. We wanted negative 3, negative 4, negative 1. We wanted these numbers so we could put that in the table. Okay, so I have negative 3, negative 2, negative 4, negative 9, negative 3, negative 2.
I got something different.
I'll come and look. Negative 2, negative 4, negative 9.
I'm negative 2, negative 1. Negative 2, 0.
Something might be wrong with your y equals. Let me see your y equals.
I got 0, 7.
Yeah. Wait. 0, negative 2. No, yours is fine. What's wrong with yours?
Oh, I thought because you were saying nothing.
Okay. You're fine.
That's fine.
You're fine too. Yeah, yours is fine. Your table might look a little different than mine, but if you scroll up and down, you will find these numbers. Okay, negative 1 was what?
0.
Okay. So those are the numbers you got from your table. So let's just graph it and we're done. Okay, so I have negative 2, down 1 is right here. Then I have negative 3, down 1, 2, negative 1, 0, and then 0 up 1, 2, 3, 4, 5, 6, 7. What's up? 4, 5, 6, 7, 8, 9. Well, let me just draw out. And then I'll come and check your answers. What's that? -2. Okay, so. Oh, you forgot your -1. Questions on that? Pretty straightforward, right? Okay, we're not gonna do any more graphs. We're just gonna get some points on here. Okay, so let's talk about this next one. Highlight this piece if you have a highlighter. Now here's something that's super important. That's it, yeah. Just gotta graph it, that's all. We're good to go. Okay, I told you that this was an easy lesson. So now there's two options. You're either reflecting over the X or you're reflecting over the Y. That's what that negative means. Which one do you think it is? So the Y. The Y would mean this. So I'll kind of give you a little bit of a hint here. The Y-axis would look like this if I had parentheses there. I know that's weird to think about, but that actually makes a huge difference. -1 cubed is different than -1 cubed like that. It's a huge difference. Okay, so this actually means reflecting over the X. Reflect over the X-axis. And that's when it's right next to the equal sign. It's okay if you didn't get it right at first because it's new. The X, when it's right next to it, there's not a parenthesis blocking it. Because again, if I put a parenthesis here, it now is going to be reflecting over the Y. If there was a parenthesis right here. Okay. Now, whenever you don't move left or right anything, can you assume where your original point's going to be? If you don't move left or right at all, where would you start? See if you remember. Like, what does it mean to move nothing? What is nothing? 0. So 0, 0 is where I'm going to start. The only time that you don't start at 0, 0 is if you move left or right. So like the first one we just did, we moved left and we moved down. Here we didn't move left or right at all, or down or up at all. So that's why we're 0, 0. So that means that it's going to be -1, -2, 1, and 2. And you can just put that in your calculator. And I'm not going to waste your time to do that because I know you know how to do it. We're going to move on to the next one. We don't have to put it in. We're done. We're going to move on.
How'd you get to 0, 0 again?
So 0, 0 is because we did not move left or right anything. So that's why we started 0, 0. You always start at 0, 0 unless you move left, right, down, or up. So just like the C and D then. For C, what is our transformation here? What does a 1/2 mean?
Reflect.
Reflect is the negative. 1/2 is the compress, I heard. Compress by 1/2. Now, what does the 2 mean for D? Stretch or compress? Good. Stretch by 2. So that's the difference between the two. It's kind of good to see a comparison. 1/2 would be compress, 2 would be stretch. Do they move left or right at all, or up or down? Do they move left, right, up, or down at all? For these two. Did we say left, right here? Up, down? No. Did we say left, right, up, down here? No. So where do we start? 0, 0, 0, 0. Just getting you used to that. The only time that you don't start at 0, 0 is if you move left, right, up, or down. And you can just put in your graphing calculator and you can actually see where it starts. Okay. So that means that again, I would be at -1, -2, 1, and 2. And we're not going to graph these because again, I don't feel like it's necessary. However, some people actually emailed me last night and asked how to put a 1/2 in your calculator. And that's okay. Just make sure that you make a note. 1 divided by 2 is the way that you put that in there in your calculator. Okay? What's that? For B. So 0, 0, one last time, means that I didn't move left or right at all, or up or down. The only time that you're going to be changing it is, look here, we move left 2, down 1, and that's why I was there. The negative where? Oh, the negative, it would have to be like this, -3. That would be down 3. Okay, because the negative's out in front, we're not going to be moving down. But that's actually a good question. Okay, the last part. Out of all the things in the test from last chapter 1, part 1, chapter 4, part 1, this is where some of you struggled because you now had to do the reverse and make your own function, and we're done after these 3. Now, I'm going to write this out on the bottom so that you remember when you're doing this. It's just that formula that we've been using, and you'll always be given it. Well, not cubed, actually. We're going to put a number here. We don't know what the number is. The problem's going to tell me what number I'm working with here. Same thing as last chapter. To the something power. We don't know the power yet. Plus K.
Why you put a number?
Because, again,
To the something power.
to the something power. Okay? It's okay. It's okay if I need to repeat myself. That's fine, but hopefully not more than once. All right. So, reflected over the x-axis. This is the one that people always get confused on, the reflecting over the x-axis versus the y. Reflecting over the x-axis means that the negative is right by the equal sign. Okay, so g of x equals, right away I'm putting that negative in because that's what it means to reflect over the x. That negative, that blue negative is the reflection. And maybe like if you're highlighting because you like the visual, that's where it's coming from, maybe so that you know when you look back at your notes that x-axis is where it's coming from. Now it says translated to the right to. So right to. Would that be inside the parentheses with the H or would it be outside with the K? From going right. Whenever you're going left or right, I heard someone say it's inside. Remember, inside the parentheses is left, right. And if you forgot that, that's okay. You can put like an LR here to show that you're moving left and right. And maybe for K, you can put a UD for up and down, just so that you remember. And you'll always be given the formula on the test, so don't feel like you have to memorize it. So if I go,
What's the K 00?
UD, a U/D for up, down. Okay, parentheses. Oops, something happened here. Parentheses, X. Okay, would I have a -2 or a +2 if I'm moving right? Good, -2. Now, here is something that's important. These guys in the very beginning, they're going to tell us what our power is, that number that we're talking about. So that 3 right here is telling me that I'm to the 3rd power. That's what that's telling me. I know this is a little bit higher of an order of thinking. Really got to put all your skills together. I get that. But you got it. So that 3 is telling me what goes there. Then up 4, would I have +4 or -4 at the end? +4, done. Again, taking it piece by piece. Sometimes it's not in order. So I always start with g of x here, equals something. I know I'm going to be working with the 5th power. It's going to stretch by 3. So is that going to be the a value, the h, or the k? Where would stretch go? Where would the 3 go for the a, the h, or the k? Very good, the a. Okay, so the 3 right here. And if you want to highlight it with the same color, you can so you remember where it came from. Then reflected over the y. Here is the one that's new to us. Is it going to be, and don't write this down, is it going to be like this inside the parentheses, or is it going to be like this outside for the y-axis? Would it be inside or outside? Careful. Outside means, yeah, inside is, that's new, so I am okay if you didn't get that right the first time. Inside, right here in red, is going to tell me that I'm reflecting over the y. And we're done pretty much, but we got to make sure to put our power in, and we're done. 5. Now, if I told you we're reflecting over the x in blue, don't put this down, you'd be right there. That's what it would mean to be reflected over the x, but we're not. We're reflecting over the y. All right, last round. Here we go. I know this is the harder of the bunch. We're going to have a 4 power here. That's important. We're reflecting over the x. So is that going to be, besides Briley's, I know that you understand that part, I heard it. Is it going to be outside the parentheses or inside the parentheses? Which one for x-axis? Very good. Riley. No. Okay, on the outside, whenever you're doing the x-axis, it's on the outside. And if you want to make a note for yourself, this is the x-axis, this is the y, so that you remember. You can see the difference between B and C. The negatives inside, the negatives on the outside for C. Now compressed by 2/3. Remember, that just means the number all the way out in front. So that guy right here. And then left 5. Would that be a plus or a minus 5 inside the parentheses? If I'm going left 5. Yeah, plus 5. And then don't forget your 4 fourth power. This is the hardest part of this one, but you guys did this last chapter, but instead of a 4, you had a 2. Like last chapter, all you had was a 2 here. That's the difference. Okay, but it's 4 now. You have a long time to do your homework. You have at least 15 minutes. Okay, take your time. 1 through 6, I'm challenging you to do more of these because of the harder ones. 7, 8, 9, and 10 are really fast. Okay, so please don't put this away right now. At least give me 5 minutes out of the 15 to do your homework and ask me questions. Putting it away right now is not an option. I want you to try it. Work together. Work alone. Work with me. I don't care what you do with that, but I need you guys to try it because what kills me is when you walk in tomorrow and say you don't get it when you had 15 minutes in class to do it. You got one? You got one? Anyone not get one? The key is right here. Check your answers right now.
Let's say about movie partners.
We partners.
Yeah, you said work.
I can work with you if you have questions. I'm not gonna do them though for you. If that makes sense. If you do have questions, I'm more than happy to come by you and answer them. You just gotta ask. You guys are doing a really good job. I can tell by your note-taking skills.